because frozen in its surface is the history of the really early periods of the solar system. Before we had lunar samples, scientists would try to put together a history of the moon and the solar system. When we had the absolute ages of the lunar rocks, that gave us a time frame. On Earth, where we have wind and rain and plate tectonics, the oldest rocks have been worn away or covered over. But on the moon, that's a surface that hasn't changed a lot in billions of years. That way, it gives us a look back at the history that's been erased on the Earth. And from the rocks, we've learned that in the earliest days of the moon, it was mostly or entirely molten. This fits with the leading theory for the origin of the moon, that early in the Earth's history, a Mars-sized body impacted into the Earth and threw off material that formed the moon. The study of the moon just really taught us about the importance of impact processes in the formation and evolution of the solar system. Understanding impacts is important today because even though we don't have the heavy bombardment that was in the early days of the solar system, it's still an ongoing process that's happening all the time. If an asteroid were ever to come towards the Earth, it's very important that we understand these processes, what's going on and how it works. The astronauts brought back 840 pounds of lunar rocks and soil on 6 different missions. There's plenty of material left that hasn't been looked at yet, so we're still getting recent discoveries.